in the last video we talked about SP2 hybridization, and now we are going to move to SP2 hybridization. Thank you once again for joining, for liking, for everything, for your support. I am really grateful. Thank you. So let's move now to SP2 hybridization. So the second is SP2 hybridization. SP2 hybridization is not that different from SP3 hybridization, but it's different. Just that I will explain the same way I explained the first one and point out the key points to note. So the first thing I would say is that it is common in the family of carbon compounds known as alkenes. So it is common in alkenes. The one with double bonds. So basically, SP2 hybridization means that we are adding one S and two P to give us three SP. When I explained SP3, I said we have one S and three to give us four SP. In SP2, it will be one S and two to give us three SP2. And so another thing to note is that it's common in alkenes. Then I would use carbon again as an example. So let's keep the part where I talk about the ground state, the excited state. Okay, basically I can start from the excited state of carbon now. And we have the excited state of carbon in the excited state to be 1s, 2s1 and 2p. So we have 1s, 2s. So we have one electron this way. That's the excited state of carbon. So for the hybridized state, it will be different because this time around we are dealing with SP2 hybridization. So that means that we need one S and two p orbitals. So this is one S and we need two of these two p orbitals. So that means we have one left. So the hybridized state in SP2 hybridization will be we have our one S. So this is the SP2 hybrid orbitals that we are forming. And we still have our PX, PY, PZ. We still have our PZ orbital here. So this has two that is untouched. This one has one each. This last one also has one. So we have three in this case because we are dealing with SP2. One S and two. So I think it's one S and two of these orbitals. I brought them together. Hybridization, and then the last one is staying below. So this is what we have in SP2 hybridization. So all of these orbitals will rearrange themselves and then they give the shape that is known as trigonal. So in this case, their own shape is trigonal, and then the bond angle between them is 120 degrees. So these are the things that you should know. The bond angle is 120 degrees. The shape is trigonal. Now another thing that I didn't mention when I was talking about SP3 hybridization is that we have single bonds throughout in SP3 hybridization, and the single bonds are known as sigma bonds. So one thing that I want you to notice is that hybridized orbital, we form sigma bonds. Unhybridized form pi bonds. So these are the hybridized orbitals, like I explained. So this is the one that is not hybridized, the one that will move from the p. So this will form the pi bond, and this will form the sigma bonds. So in normal alkenes, let me use 18 as an example. So 18, we have something like this. So for this particular carbon atom now, let's say this is carbon atom we are dealing with. So it has 3 sigma bonds. 1, 2, 3. I told you that they are hybridized before sigma bonds. So it has 3 sigma bonds and 1 pi bond. So let's count. 1, 2, 3. So the last one will be pi bond. So here, if it is these two carbon atoms, we have a particular sigma and another one to be pi bonds. So this is another thing that you should note in our case in SP2 hybridization. We have 2 kinds of bonds here. We have sigma and pi. I hope you understand. And the bond angle is 120. So the percentage character now, the percentage character in this case for S, it will be 1/3 since we have 1s and we are forming 2. 1/3 multiplied by 100, and that should give us something around 33%. So we have for P to be 2/3. We have 2 to the power of 3 multiplied by 100%. So that should give us around 67%. So those are the things that they can ask you. They can ask you for which compound is there. They can ask you for the shape, the geometry. They can ask you for the bond angle. They can ask you for the bond type. For the bond type. And they can ask you for the percentage character. So the last one. So that will be all about SP2 hybridization. For SP hybridization, we'll deal with it in the next video. So do well to join, do well to like, subscribe, and share, and drop your comments. Thank you.